Hi, my dear students. My name is Momin Ali Shetty. So, as we are having a pandemic days of COVID-19, so many students are facing the problem with mathematics. So, many students are making phone call to me. They're asking doubts to me. So, yeah, I have started this program. This program name is Brain Booster Program. Brain Booster of Mathematics. So as this program daily, I will teach a topic, a shortcut technique. It may be a shortcut technique. It may be topic of your textbook. A clear explanation, step-by-step explanation I am going to give now. Okay. So yesterday, many students have made call to me and they have asked about the HCF, highest common factor, and the shortcut method. They asked me to explain. That's why today I'm going to explain about the highest common factor. Let's see the what is highest common factor. Now see HCF. What is HCF? HCF is nothing but it is the largest positive integer which divides two or more given numbers without remainder. Without remainder means with remainder zero. HCF is nothing but it is the largest positive integer which divides two or more given numbers. Means the HCF is the common factor of all given numbers. All given numbers. So it divides each of number without remainder, means remainder must be zero. As we know that the numbers are two, whatever the given numbers may have the more common numbers, common divisors, common factors. It may be have two common factors, maybe have four common factors. But which one we can consider as HCF here? Means the largest common factor is known as highest common factor or greatest common divisor. The other name of highest common factor is the greatest common divisor or the greatest common factor. That's why we are calling them as HCF or GCD or GC or HCD. These are the names of HCF. For example, I am taking 15, 15 and 20. The 15 and 20. These are the two digits, two numbers. We need to find the HCF. And usually, generally we take we divide 20 with 15. Okay, divide 20 with 15, and we can find it. For example, 15 ones are 15, and remainder is 5. Again, with 5, we need to divide 15. 5 threes are 15. So remainder is 0. So the year we consider 5 as here we consider 5 as HCD. But there is one shortcut method. See, only just no need of dividing here. The shortcut method is just to find the difference of 15 and 20. The difference of 15 and 20. So 20 minus 15 is equal to 5. So only just we need to say, we need to check this difference whether it is factor of 15 and 20 or not. We have to see that. Simple. Only just we have to see that whatever we got the difference must be the factor of 15 and 20. If it is factor, no doubt it might, if compulsory, it must be the GCD of the given numbers. So already we have proven much by sense. So easily we can find by find the difference of the given two numbers. Let us take one more example. One more example for GCD. For example, I am taking 18, 32. 18 comma 32. We need to find the GCD of this 18 comma 32. Now let's see, as we discussed that, let us find the difference of 32 and 18. It is nothing but 40. But see, if you see that 14 is not a factor of 32 and also 18, then in this case, what we need to do means only just let us take the factors of 14, just to factorize it. And what do you get? 2 and 7, and one more factor 14, and one more factor 1. These are the factors of 14. In this, we need to take the least factor of 14. So that is to be considered as the GCD of 32 comma 18. It's simple. What the point? Only the in this case is if the difference is not a factor of given two integers, then here we need to factorize the difference, and we need to select which is the least common factor. That common factor must be 32 and 18. Must be factor to the 32 and 18. For example, in the given, we have got the years, for example, we have got here 4 digits here. In these 4 factors of 14, none of them is factor of 32 and 18 then. So finally, we need to take 1 as a GCD. Got the point? So that's why, as we have got the 2 is the common factor of 32 and 18, here 2 be considered as GCD. Got the point? Now let us take one more example. Now. One more example. 22 and 17, for example, 22 and 17. What is the difference between 22 and 17? It is 5. It is 5. See, as we have discussed that 5 is not a factor of 5 is not a factor of either 22 and 17. So as we have said, I have said that let us take the factors of 5 and 5 comma 1. Here 5 is not a factor of 22 and 17. It is not a common factor of 22 and 17. That's why the final answer is 1. So 1 is the GCD of 22 and 17. Finish. All the point. So like this, we can find the HCF of 2-digit number by using this shortcut technique. But is it applicable for 3 digits and 4 digits also? Yes, it is applicable for 3-digit number and 4-digit number also. Then how can we find the HCF or GCD of 3 digits or 4 digits of number? Let's see now. Let us take 3 numbers now. Say, I'm taking 15, 22, and I'm taking 31. So let us take these two differences. The difference of 22 and 15 is 7, and the difference of 22 and 31 is nothing but 9, and the difference of 31 and 15, 16. So here we have got the 3 numbers, 7 and 9 and 16. In this, we need to take the smallest number. What is it? The smallest number should be taken. So in this 7 and 9 and 16, the smallest number is 7. And we need to check it whether the 7 is the common factor of 15, 22, and 31 or we need to see that. It is not a common factor of any numbers. So we need to take the factorize as it is prime number. So 7 comma 1, it is only it has the 2 factors, 1 and itself. So as 7 is not a factor of any of this number, then 1 is considered the GCD of 15, 22, and 31. Simple. Only just we need to find the difference of 22 and 15 and 31 and 22. In very simple way, we can find this GCD. So like this, it can be applied for 4-digit numbers also. It can be applied for 4-digit numbers also. Let us see the one more problem. Let us take the four numbers now. Sorry, 22, 13, 80, and 71. Now let's see that the difference. Let us find the difference of any each two numbers now. I'm finding the difference of 22 and 13 is 9. The difference of 13 and 18 is 67. And the difference of 80 and 71 is 9. And the difference of 71 and 22 is approximately 49. So let's see now, we have got the four digits again, 9, 67, 9, and 49. As I said that the least number is 9. So as 9 is a factor of any of this number, so that's why let us take the factors of this one, and 3, and 9, and 1. So the least one is 3, but here and 1 also there is the least one. So let us see that 3 and 9, but none of these three are, this 3 comma 9, both are factors of these four numbers. That's why the final answer is 1. So our 1 is the GCD of these four digits. Got it, my dear students? So this is the amazing shortcut technique to find the greatest common divisor of or highest common factor of the given digits. So practice it. If you have any doubts, please you can message me in the WhatsApp. You can send the message. You can ask me any doubt in the next live session. I will clarify the doubt. Thank you very much.